All right, guys. So we are on our last chapter of the year here. So we're working on chapter 9. So chapter 9, I know that we kind of went back and forth between a bunch of things, but chapter 9 goes back to our quadratic functions. Okay, so a quadratic function, if we remember correctly, a quadratic function is anything that looks like f of x is equal to ax squared plus bx plus c. Okay, so we're going to be working with this trinomial again, where we have our highest degree being 2. Okay, now again, it just has to be in this form. That doesn't mean that it always has to have three terms. Your b and your c could be 0, and you could just have a function like f of x is equal to 3x squared. That's a quadratic function. Okay, so it doesn't have to have 3 terms, but it has to have the highest degree term being a square. So we'll never be working with cubes or fourth powers or fifth powers. The highest exponent will always be a 2. Okay, so this is what we're going to be working with. We're going to be working with our quadratic functions. But in this first section that we're going to work with, we're going to look at how to graph our quadratic functions. So if we're looking at graphing quadratic functions, there are a good amount of parts that we want to understand how to find and understand how to work with when we graph our quadratic functions. So we're going to go through all of them one at a time, but the first thing I want to talk about is just the shape of what a quadratic function will look like. We've done a bunch of different functions. We've done linear functions. We've done exponential functions, radical functions, all these different things. And we've always talked about what they've looked like. So a quadratic function, when graphed, okay, will have the shape of what we call a parabola. Okay, parabola. A parabola is essentially just a U shape. So all the graphs that we're going to be working with now will have this U shape to it. Okay? Now, obviously, it could be going up, it could be coming down, it could be going like this. But it'll always have a U shape to it. So, that's the first thing we want to talk about, the shape of it. So the shape is always a parabola. Now, because we have this U shape, or this parabola shape, we also are going to have what we call an axis of symmetry. All right, now an axis of symmetry is the, if we remember correctly, a line of symmetry is a line about which we can flip something over and it's the exact same image on both sides. Well, that's essentially what the axis of symmetry is as well. It's a line that if I were to flip this parabola over, like fold it on this line, we would have the same image on both sides. Okay, so we have this axis of symmetry as well. Now, this axis of symmetry will also give us another important part of our parabola, which we call the vertex. And the vertex is the point, which is the highest or lowest point of our U shape. Okay, so it's the point of the parabola that falls on the axis of symmetry. The vertex will always fall on the axis of symmetry. Okay? Now that point, that vertex, like I just said, it's either the lowest or the highest point, depending upon which way the vertex or the graph is opening. So that vertex could either be our maximum or our minimum point. Whoop. Okay? It's either going to be the highest point or the lowest point on the curve. Okay, so there's 4 different things that we need to know. We need to know that the shape is called a parabola. We need to know the axis of symmetry. We need to know the vertex. And we need to know the maximum or minimum point. Okay? Now, one of these things we'll actually be able to find if it's given to us as a function. We'll be able to find one of these things as a formula, and that is the axis of symmetry. So the axis of symmetry we can actually find by doing the formula negative b. So I'll put it as x equals negative b over 2a. Okay, so the axis of symmetry can be found by doing the formula x equals negative b over 2a. Well, what is b and what is a again? Well, if you remember, the standard form is ax squared plus bx plus c. There's your b, there's your a. So if I want to find the axis of symmetry, I just take this b, I take this a, I plug it into my little formula here, and that'll give me my axis of symmetry every time. So axis of symmetry is actually pretty simple to find. All right, vertex we'll always know is the highest or lowest point, and that will also be the maximum or minimum. And we just have to know whether it's a maximum or minimum point. And again, that's pretty simple. If the U opens up, it'll obviously be a minimum point. If the U were to open downwards, it would be a maximum point. Now, the last 2 things I want to talk about, our domain and our range. Okay? Now, we always talk about this when we talk about our new functions, so we obviously are going to talk about it here as well. The one easy one of this will be the domain. The domain will always be, and if you remember this is how we write it, we say x such that, but the domain is always going to be x is a real number. Okay? So our x is always all real numbers. All right, and we talked about this before. In order for it to be a function, every x has to have a value, so our domain is going to be all real numbers. My range, that's going to depend on whether we have a maximum or a minimum. Obviously, if we have a maximum, it'll always start y such that. If we have a maximum point, it'll be y is less than every value to whatever the maximum is. Meaning you'll say y is less than the maximum, whatever the maximum number is. Do not put max, put the number, right? So if this was a y value of negative 2, you would say y is less than negative 2, or y is greater than negative 2. But it's whatever the maximum value is. If it's a minimum, you'd say y is greater than whatever the minimum value is. And again, you're working with the y value, not the x value, because obviously range deals with y. Okay? So the domain is always x is a real number. The range will be y such that if it's a maximum, it'll be less than the maximum, And if it's a minimum, it'll be greater than the minimum. So these are the things that we're going to be looking at with all of our parabolas, with all of our quadratic functions. We need to know the axis of symmetry, where the vertex is it a maximum or minimum, what is the domain, and what is the range. All right, so let's try and find all of these different parts with a single function. So let's say I had the function y equals 2x squared plus 4x minus 3. And I wanted to find the vertex, the equation of the axis of symmetry, the y-intercept, whether it has a maximum or minimum, and the domain and range. Okay, so I'll put that all on the side. We want to find the vertex. We want to find the axis of symmetry. I'll simplify that or shorten it to the AOS. This is the axis of symmetry. We want to find the y-intercept. We want to find, is it a maximum or minimum? And we want to find, what color haven't I used? Purple. We also want to find what is the domain and what is the range. All right, so we have a lot of things that we want to find here. The good thing is, once we find one of them, it kind of gets the ball rolling for everything else. Okay? It's not like we have to find all of these separately by doing one thing and then another thing, and it's going to take us forever because we're looking for 6 different things. So we're going to find these a little bit out of order. We're not going to find the vertex first. We're going to start with finding the axis of symmetry. Now, the reason we're going to find the axis of symmetry first is because we already know what the formula is to find the axis of symmetry, right? We said before the axis of symmetry is found by using negative b over 2a. All right, so which one is a, which one is b, which one is c? Well, if we remember, the coefficient for the x squared, that's a. The coefficient for the x, that's b. And the number by itself, that's c. So we have our a, b, and c. All we do is we plug it into negative b over 2a. So the axis of symmetry is going to be negative, b is 4, over 2 times a is 2. Let me write that. There we go. And now I just simplify it. So it's negative 4 over 2 times 2 is 4. And negative 4 over 4 becomes negative 1. So my axis of symmetry is x equals negative 1. That's the axis of symmetry. Done. So there's one part of it. Now, once we have the axis of symmetry, excuse me, the next easiest thing to find is going to be the vertex. Because if you remember correctly, the vertex falls on the axis of symmetry, meaning that x value of negative 1, that's the x value of the vertex. The vertex will always be a point, an x comma y. By finding the axis of symmetry here, knowing that the axis of symmetry is negative 1, or x equals negative 1, that tells me that the x value of the vertex is negative 1. So I just have to find the y value. And how do I find the y value if I know the x value? Plug it into the function. Take this negative 1, plug it into here, and solve for y. So I'm going to replace all of my x's with negative 1, and I'm going to solve for y. Negative 1 squared is 1. 4 times negative 1 is negative 4. 2 times 1 is 2. Whoop, that should not be a 2. That should be a y. 2 minus 4 is negative 2. And negative 2 minus 3 is negative 5. So the y value of my vertex is negative 5. So my vertex is negative 1, negative 5. Okay, so you see how this is kind of now rolling here? By finding the axis of symmetry, we're able to find the vertex because all we have to do is take that x value and plug it back in. Now, we have 4 more things to find. Y-intercept, max or min, domain, and range. Well, one of these is very simple, right? You should all be saying domain. We should all already know the domain. We said it before, the domain is always x such that x is a real number. It's always that. Always a real number. Okay, so that was simple. So now we're left with 3 things. Now, we didn't really talk about y-intercept here. Let's talk about the y-intercept for a second. The y-intercept is c. The y-intercept is always just c. Whatever your c is, that's the y-intercept. So if you want to write that down somewhere, the y-intercept is always equal to c. So if I go back up here, what is my c? My c is negative 3. So my y-intercept is -3. That's it. Okay. Now, let's look at the range. We'll do max or min last. Let's look at range here. So we said the range... Actually, no, we need to do max or min before we can do range, right? Because we need to know whether it is a maximum or a minimum in order to do the range. So let's talk about max and min then. So the maximum and minimum, we need to determine whether this is a maximum or a minimum. Now, you would think, well, let's graph it, right? Let's just put this on a graph and figure out whether it opens up or down. Well, there's actually an easier way to do that. You can determine if a parabola opens up or down by looking at A. Okay? In this case, my A is 2. If A is positive, the parabola opens up. Okay? Meaning it's a U shape like that. If A is negative, it opens down, almost like an N. So if your A is positive, you'll always have a minimum. If A is negative, you'll always have a maximum. So in this case, my A is positive, so that means I am going to have a minimum value. All right? So then the question is, what would that minimum value be? What is the minimum value? Well, we said the vertex is the minimum or maximum value. So when writing the minimum or maximum value, you're only taking the y of the vertex. You're going to look at what we got for y. That's your minimum or maximum value. So here, my minimum value is going to be y equals -5. Again, you see how everything kind of connects to each other? Once you find one thing, you're able to get everything else by just doing one little thing more. Okay? So we have the vertex, we have the axis of symmetry, we have the y-intercept, we know it's a minimum, we know the value, we have the domain. The last thing is the range. And now that we know it's a minimum, now we can do this. So the range is y such that, because it's a minimum, and we know the value, we said if it's a minimum, it's going to be y is greater than or equal to. I should have put equal to. Okay, it's always or equal to as well. So if you took any notes, change that. It should always be or equal to as well. So we know it's greater than or equal to whatever my value is here, which is a -5. And there's my range. So again, everything kind of builds off of each other. Always find the axis of symmetry first, then you find the vertex. The y-intercept is basically there for you. The domain is always the same thing. The max or min, you look at A. The value of it is your y value of the vertex, and then the range, you use that and write it out however we need to write it. All right, so I've given you a function up on the board here. I would like you to find all of those different parts again. I would like you to find the vertex. I would like you to find the axis of symmetry. I would like you to find the y-intercept. I would like you to find whether it is a maximum or a minimum and what the value is. I'd like you to find the domain and the range. Okay? So I would like you to find those 5 things. So pause the video, take 5 minutes, try this on your own, and when you unpause it, we'll see if we got this correct or not. Okay, so here are my answers. We should get a vertex of 1, -2. Actually, let's go in order here. Axis of symmetry, we should have done this first. X is equal to -b/2a. My A is negative 3, my B is 6, my C is negative 5. So I plug these in. Negative 6 over 2 times negative 3. 2 times a negative 3 is negative 6. Negative 6 over negative 6 is 1. So the axis of symmetry is x equals 1. That is the x value of my vertex. So I take that, I plug that in for x, I solve for y. 1 squared is 1, 6 times 1 is 6. Negative 3 times 1 is negative 3. Negative 3 plus 6 is 3. 3 minus 5 is negative 2. So my vertex is 1, negative 2. My y-intercept is whatever c is. My y-intercept would just be negative 5. Do we have a max or a min? Well, A is negative, which means it opens down like an N shape. So that means that we have a maximum value. And the maximum value is whatever the y value is for the vertex, which is negative 2. The domain, always x is a real number. The range, because it's maximum, it's less than or equal to. So it's y such that y is less than or equal to negative 2. Again, we use the value that we got for the max or min value, or the max value in this case. Okay, so now that we know how to find all of these points, now we need to be able to graph a parabola. Okay? Graphing a parabola is actually very simple. All right, and the reason it's simple is because we're going to go by a specific rule. And we'll talk about that rule in 1 second. But no matter what, in order to graph a quadratic function, we need to know, excuse me, we need to know the vertex. That's a 100%, we need to know that. So, let's say I wanted to graph the function f of x equals x squared plus 4x plus 3. Okay? So if this is what I wanted to graph, the first thing I need to find is the vertex. And in order to find the vertex, I need to find the axis of symmetry. So I need to do my negative b over 2a. That's first. Again, a in this case is 1. If there's no coefficient, we know it's 1. B is 4, and C is 3. So I'm going to plug it all in here. So I'm going to get x is equal to negative 4 over 2 times 1. So that's going to be negative 4 over 2, which is going to give us negative 2. So the x value of the vertex is negative 2. Now I'm going to take that negative 2, and I'm going to plug it back in to get the y value. I'm going to do that over here. So we have negative 2 squared plus 4 times negative 2 plus 3. Negative 2 squared is a positive 4. Remember, when you square a negative, it becomes positive. 4 times negative 2 is going to give us negative 8 plus 3. 4 minus 8 is negative 4. And then plus 3 will give us negative 1. So my vertex is going to be at the point negative 2, negative 1. Okay. The next thing we need to know, will this open up or down? And again, we should be able to tell that by looking at A. A is positive, so since A is positive, this will open down. Open up. Open up. Hopefully you all caught that. So we're going to open up here. So that means that this is a minimum value. Okay. That's all we need to know in order to graph it. Because now we go by a simple rule. And we call this rule the 1A, 3A, 5A rule. Okay, so let me explain here. The 1A, 3A, 5A rule says when I am graphing a parabola, okay, so I'm going to create my XY chart. I always start at the vertex. So I'm going to start at the point negative 2, negative 1, and I'm going to plot my point. So that is the vertex. In order to get all of your other points on a parabola, all we have to do is follow the 1A, 3A, 5A rule. A is still talking about this A here. So for every parabola, it's going to be a little different based upon your A in terms of how I find my other points. But I'll always look at A here. So 1A is really 1, in this case, times 1. So in this specific parabola, where we're going to be working with the 1 times 1, which is 1, 3 times 1, which is 3, 5 times 1, which is 5. So in this specific parabola, it's the 1, 3, 5 rule. And what that means is, from my vertex, I can go over 1, up 1, and put a point. That's the 1 part. I go over 1, up 3. I go over 1, up 5. So what we're doing is we are following this pattern, this over 1, up 1A, over 1, up 3A, over 1, up 5A rule to get all of my different points. And then what I do to the one side, I have to do it the other way as well. Instead of going to the right one, I'm going to go to the left one. So I'm going to go over to the left, up 1. Over to the left, up 3. Over to the left, up 5. You will always go over 1, okay? So even if this was, let's say, a 2, 6, 10 rule, because my A was 2, you'd still go over 1. You would just go up 2. And then over 1 and then up 6. And then over 1 and then up 10. It's always over 1 no matter what. But now we just connect our points in a nice parabola shape, in a nice U shape, as U as you can get it. I know sometimes it may look like a V, but you want to make it look as U as possible. And there's my graph. All right, so again, if you follow the 1A, 3A, 5A rule, it'll make graphing it a lot more simple than normal. So let's try one more. Let's do one more together. Let's say I wanted to graph the function f of x is equal to 3x squared minus 6x plus 2. Okay. So again, no matter what, got to find the vertex first. Got to know if it opens up or down. So we find the vertex first. We do our axis of symmetry, negative b over 2a. This is my A, this is my B, this is my C. So negative B, all right, so B is negative 6. So this is really saying negative 6 over 2 times 3. Okay? This negative always is there. B is negative 6, so it's negative 6. Negative 6 is just positive 6. 2 times 3 is 6. So my axis of symmetry is 1. So the x value of the vertex is 1. Now to find the y value, I plug it in. So I'm going to plug it in. So I have 3 times 1 squared minus 6 times 1 plus 2. 1 squared is just 1. So this is 3 times 1. 6 times 1 is 6. 3 times 1 is 3. 3 minus 6 is negative 3. And negative 3 plus 2 is negative 1. So I have my vertex at 1, negative 1. Then I ask, all right, is this going to open up or down? A is positive, so it's going to open up. So now I go to my XY chart. I'm going to plot the point 1, negative 1, because that's the vertex. So I plot the point 1, negative 1 right here. There's my vertex. So let's Let's make that in a different color just to make it a little easier to see. Okay. So now I need to follow the 1A, 3A, 5A rule. So in this case, in this specific problem, my A is 3, right? We knew that from up here. My A is 3. So this is not the 1A, 3A, 5A rule. This is going to be 1 times 3, which is 3. 3 times 3, which is 9. 5 times 3, which is 15. So in this specific parabola, this is going to be the 3, 9, 15 rule. So what that means is from my vertex, I will go over 1, up 3. Make a point. Over 1, up 9. Make a point. Now, obviously, I can't go over 1 and up 15 on this specific problem, but if I could, I would. I'd go over 1, and then I'd go up 15. I'm going to do the same thing on the other side. I go back to the vertex, and instead of going to the right, I now go to the left. I go over 1, up 3. Over 1, up 9. And then again, I would go over 1 and up 15 if I could, but I can't. I now take my points, I plot them, or I connect them in a nice U shape, or as much of a U shape as I could possibly get here. And there is my parabola. Okay, so as long as you understand how to use the 1A, 3A, 5A rule, graphing a parabola is extremely simple. All right, just remember, and this is, I know we've only done an opening up one, but if it opens down, instead of going over and up, you would go over and down. Okay, it would just be, you'd go over 1, down 3, over 1, down 9, over 1, down 15. Okay, so that's how we use the 1A, 3A, 5A rule.